Hello, sir. My name is Sharvin. So I am here to present about DFN 40283 Routing Essentials problem-based task. So for the task scenario, you are working as a network administrator in Penang International Airport. This airport is a three-level building. You need to design static routing network scheme in the company to serve a few employees on each floor. Besides that, you need to apply the standby router among the distribution router using the HRCP protocol. Floor 1 assigned for distribution 1, floor 2 assigned it is for distribution 2, and floor 3 is for ICT department. Users in floor 1 and 2 must get dynamic IP address from ICT router. All departments must be able to communicate with each other and web server, but at the same time, they have their own separate working networks except for floor 1 and floor 2 users. This airport had purchased additional new three Cisco 2960 switches for each floor and two Cisco 1941 router for distribution. So this is task one. Design the additional topology based on current network. A ICT router must connect to distribution routers using floor three switch. As you can see, the Solar 3 switch is connected with the ICT router and at 12960 switch per floor of the building. As you can see, we added two switches, which is switch 1 and switch 2 is connected to PC. Floor 1 and floor 2 switches must connect with their own distribution router. Floor 1 and floor 2 switches must design with HSRP support connectivity. So for task 2, plan the addressing scheme table. IP address for DMZ LAN and ISP networks is already pre-configured. So for B, create IPv4 addressing table for additional network including ICT LAN. Floor 1 and floor 2 users should get dynamic ICT from router. So this is the network addressing scheme table for ISP for interface S000. IP address is 10.100.100.2, and for interface G0 slash 0, 255.255.255.252. So for ICT, the interface G01 is connected with IP address 10.1. For serial port, it is 10.100.1. For the gigabit Ethernet port, 10.1.1.1. So for the distribution router, the interface G00 is connected with 10.1.1.12. For gigabit interface 0 slash 1 is 10.1.3.1. For distribution router G0 slash 0 is 10.1.1.22. For G0 slash 1, 10.1 0.4.1. So for PC1 and PC2, there's no IP address because it must receive dynamic IP address from the switches. So for HSRP Virtual Gateway, 10.1.1.254. For DNS server and web server, it is already configured with 10.10.10 and 209.165.200.226. So here I configured ICT router with IP address 10.1.1 and subnet mask is 255.255.255.0 for the interface G0 slash 0, and I verify it with the IP interface brief command. As sir can see, the G00 is assigned with IP address and the status is up. So this is for the distribution router 1, which is configured in G0 slash 0. The IP address is 10.1.1. Subnet mask is 255.255.255.0. And for the interface G0 slash 1, the IP address is 10.1.3.1 with subnet mask 255.255.0. And I use the IP interface brief command to verify the IP addresses. So for the distribution router 2, it is configured with IP address in interface G0 slash 0 with 10.1.1.22 and subnet mask is 255.255.255. And for the interface gigabit Ethernet 0 slash 1, the IP address is 10.1.4.1. The subnet mask 255.255.255. And I used the show IP interface brief to verify the IP addresses are assigned correctly.
Hi, so good morning. My name is Jayatri Subramaniam. So I would like to continue to task 4, which is configure static routing for distribution routers and ICT routers. They are given 3 questions, which is A, configure default static router for connection from ICT router to ISP, and then configure static route for related remote network from ICT router. C will be configure static route for related remote network from configuration. As you can see, we are attached some of the screenshot that we done in Cisco Packet Tracer. So now I will like to explain about those screenshot. So in task 4, we are required to configure static routing between the ICT router and also with two distribution router to ensure all the device can communicate with each other internet with each other using the internet. So first we begin with the ICT router. We configure a default route using the command IP, as you can see on the screenshot, which the IP route will be 0.0 00 and then 000. The IP is 10.100.102. This allows the ICT route forward all unknown traffic to the ISP. Next we add specific stated route to the subnet managed by the distribution router. For example, to reach the network on floor 1, which uses the IP as 10.13.0. The subnet we add was common IP route 10.1.3.0. The subnet mask will be 255.255.255.0. 10.1 and 1 and 12. Similarly, to reach the floor on 2, we also configure the IP as 10.1.1, 10.1.4.0, and also the IP route will be 10.1.4.0. The subnet mask will be 255.255.255.0, 10.1, 1 and 22. To be continuous, then we move on the distribution routers, which is distribution router 1 and distribution router 2. Both of them must know how to reach the ICT LAN and the web server. So we can configure static routes like IP route 10.10.10.0, 255.255.255.0, 10.1.1.1, and the IP route will be 209.165.200.225 forward to any request destined for the ICT department or the web server via the ICT router. After the configuration, we also can verify connectivity using the ping tool in the Cisco Packet Tracer to confirm all the routers and end devices can reach one to another. Moving to the task 5, so the task 5 is required to apply HSRP protocol to distribution routers. There are two questions, which is A, plan and decide which distribution router should be active and also standby. B is configure standby router with priority 150. So as you can see the screenshot, they are having distribution router 1 and also distribution router 2. So let me give the explain about that. We are required to apply the host standby router protocol known as HSRP between the two distribution router to ensure high availability for user on floor 1 and also floor 2. In our configuration, we decide the distribution router 1 will serve as the active router, while the distribution 2 will act as a standby router, which they got asked on the question. And also the decision is implemented by setting higher HSRP priority value on distribution router 1. Especially we configure it with a priority of 150, while distribution router 2 we are given was default HSRP priority of 100. The prim command was also applied to both routers, allowing them to active claim the role of active router if their priority is higher and they come back online after a failure. And also we configure the share virtual IP address 10.1.1 on both routers under their 0/0 interface. This virtual IP act as the default gateway for all PCs on floor 1 and also floor 2. The use of the virtual IP ensures that even if the active router fails, the standby router will take over immediately and device will continue to route traffic without any changes to the configuration. Okay, based on the simulation packet tracer, we also verify if the distribution router 1 is shut down or disconnected. The distribution router 2 automatically become the active router. So that's all from me, sir. Thank you very much.
Greetings, sir. I'm Maitri Shivlingam. Today I'm going to talk about DHCP configuration, making our ICT router the central traffic controller for automatic IP address assignment in the PBU LAN network. We'll define IP ranges, exclude addresses for static assignments like routers and printers, and also specify the DNS server, which is 10.10.10.10. Also, the network's translator for web addresses. Naming our DHCP pool as PBU LAN helps with configuration. We are excluding the first 10 IPs for static use and another specific IP which is 10.1.4.10 for devices on different network segment like different distribution router. Distribution routers act as DHCP relays, like mail carriers forwarding IP addresses requests to the ICT router. Lastly, while the current configuration shows the different subnet for potential distribution router 1 and 2 devices, the requirement is for them to be on the same subnet, necessitating an adjustment to the network configuration of our DHCP pools to ensure consistent addressing across these locations. Now let's verify network communication, the testing phase to ensure all the configured devices can communicate to each other. Successful ping result from the ICT router to 10.1.1.22 and 10.1.1.12 show direct connectivity with no loss. Importantly, the successful ping to 10.100.100.2 on a different subnet confirms our routing is functioning correctly. Examining the ICT router's IP configuration reveals its address, which is 10.1.1.1. Subnet mask its role as the default gateway and the correct DNS server, which is 10.10.10.10. Similarly, the PCB's DHCP obtained configuration shows a valid IP address which is 10.1.3.3, subnet correct default gateway which is 10.1.3.1, and the specified DNS server confirming our DHCP setup is working. Troubleshooting connectivity issues would be involve checking physical connection, IP settings, firewall rules, and also routing configuration. Ultimately, verifying with ping and IP configuration analysis confirms our network setup and aids in identifying and resolving any communication problems. That's all from me. Thank you.